In this video, I'll show you how to write an algebraic expression without negative exponents. This is part 4 in the series. Starting with question 1, we have this expression being divided to this expression. We'll start off with the numbers. 8 divided by 4 is 2. A to the power of 3 over a to the power of 5. That's like saying a to the power of 3 minus 5, which gives us a to the power of negative 2. Now I know the whole point of this lesson is to write algebraic expressions without negatives, but keep it like this for now. We'll worry about the negatives later. B to the power of negative 5 over b to the power of negative 1, and that's like saying b to the power of negative 5 minus negative 1. Two negatives beside each other is plus, so negative 5 plus 1 is b to the power of negative 4. And lastly, we have c to the power of 3 over c to the power of 3. Since they both share the same exponent, the c's cancel out. Where we are left with 2 times a to the power of negative 2, this part, times this part. And remember, this a to the power of negative 2 can be switched to this format. Similarly, this can be switched to this format where we get 2 times 1 over a to the power of 2 times 1 over b to the power of positive 4. Combining all of this together, 2 over a to the power of 2, b to the power of 4. Now we can move on to question 2. In question 2, what we have is a quotient being powered by negative 2. If you ever run into a situation like this, just remember this little technique. Let's pretend you had a over b to the power of negative c. You can flip a and b, where it becomes b over a, and you can switch the sign, becoming only c. So we'll use this technique for question 2. My denominator will become my numerator and vice versa, where I have 6x to the power of negative 3, y to the power of 5, over 2x to the power of negative 1, y to the power of 4, all powered to positive 2. Now we can do the same thing as before. Let's start with the numbers. 6 divided by 2 is 3. X to the power of negative 3 over x to the power of negative 1. That gives us, take a look, x to the power of negative 3 minus negative 1. That's a positive. Negative 3 plus 1 is negative 2. Y to the power of 5 over y to the power of 4. That's easy. That's simply y to the power of 2. Now we will distribute this 2 to each of these components. 3 to the power of 2 is 9. X to the power of negative 2 to the power of 2 is x to the power of negative 4. And y to the power of 2 is simply that. We're almost done. All we have to do is make this 1 over x to the power of 4. That stays at the top. That stays at the top, leaving us with 9y squared over x to the power of 4. You're probably wondering why I put these two dots. I just want to show that there's a 1 and there's a 9 multiplied to it, and so is this, and that's all. And so there you have it. 2 more examples on how to write any algebraic expression without negative exponents.